All right, this is general problem number 14, part 2. So we're going to start with number C, or letter C. C. Okay, so it says if the maximum tension force that the string can withstand is 3 newtons, how much charge must be added to the ball in order to break the string? So yeah, you're going to need this information. So you will still need this. So hold on to this. All right, or just keep it handy. Yeah, it is going to be, this can be a little confusing. So previously, what we did was we had our force tension is equal to the force of gravity plus electrostatic force, right? And those were equal. So we found that, and we found the force tension to be 2.272 newtons, all right? And it says if the maximum tension the string can withstand is 3 newtons, how much charge must be added to the ball in order to break the string? Well, this is going to change, but this isn't, right? So our force gravity isn't going to change, but this is. And we know the force tension needs to get to 3, and then it's going to break. So we can redo this as 3 newtons is equal to our force of gravity, which that's not going to change. Let's see what that was. Right here, 1.372 newtons. Okay, so what would we add on to that to get to 3? And let's see here. I'm going to do 3 in my calculator. 3 minus 1.372. That's going to get me 1.628 newtons. So we need to increase this to 1.628 newtons in order for the string to break. Keep in mind for the question is asking how much charge must be added to the ball. So how much charge just added to that one in order for the string to break. So we need to break this down even more, all right? But we do know that in the end, we need our electric force to be 1.628 newtons for it to break, all right? And all the other stuff, we also pretty much already know, right? However, usually it's easier in chemistry or physics if we rearrange our equation to the thing we want to solve for. So yeah, before I do that, why don't we do that? So force energy is equal to the K times Q1 times Q2 times R squared. So we know this, we know this, we know this, we know this. We want to know what we would change to this, our first charge, in order to get to this new value, right? So R squared. So we're going to get times R squared. And then, well, that would be equal to K times Q1 times Q2, right? Well, I could just divide by K times Q2, divide by K times Q2. So I will get force energy times, or force electrostatic, times the radius, times our constant, times the charge of 2 to equal the charge of 1. So that would be 1.628 times, what's our radius? What was our radius before? 0.05. Remember, that's squared, so I'm just going to change this to 0.0025. Right, you guys can see 0.0025. Our K, all of that over our K, which is 9 times 10 to the 9th, times Q2, which was just, what was that, 1, 2, 3, 4, 2, 5. Okay, what do you get for that? What do you get for that? Let's see. If we did that, we should get 1.628 times 0.0025. For that, we get 0.00407. Divide that by 9. Alright, so I'm going to do a little rounding here. So I got 1.8, it's really 1.80888, and then I'm just going to round to 1.81 times 10 to the negative 8th. Okay? And that would be coulombs. However, it's asking how much charge must be added to the ball in order to break the string. Okay, so this is where it gets a little confusing. So this is going to be the total charge needed to get to your 3 newtons on the tension of it. So 1.81 times 10 to the negative 8th coulombs. And then we know the ball had originally had Q1, right? Right here, this much. 10 nanocoulombs. Okay? So that is let's see here. It's to 7, right? There was 7 zeros. 1, 2, 3, 4, 5, 6, 7 coulombs, plus whatever we need to add to it, right? To the X, I'm going to do that. It's the charge we're adding to get to those 3 newtons. So just solve like you would any other problem. You're going to have this subtracted by this amount. All right. And if you did that, if you type this in your calculator, you were going to get 8 equals 8.0, it says 088, so we'll just do 809 times 10 to the negative 9 coulombs of charge that you need to add in order for that string to break. What does our answer key says? The answer key says 8.00. 00, so times 10 to the 9th, negative 9th coulombs. So, because of the rounding and things like that, that's why that happens. But yeah, definitely a little tough on